Yes. Sasha, you can unmute.
Yes, please.
You can unmute and lead us now out of prayer.
Okay. Okay. Almighty Father, thank you for the gift of life. Thank you for enabling us see this new day. Thank you for enabling us join the meeting as we are in the lesson. Help us understand everything that we are going to be taught. Help us be focused and let us not be diverted. Send your Holy Spirit to guide us and be with us throughout this lesson. In Jesus' name I've prayed and believed. Amen.
Amen. Thank you so much, Sasha, for the word of prayer, and you are most welcome, everyone. Thank you so much for joining the session. Today, we are going to look at physics. That is the subject we are looking at. And when you look at my screen, I've displayed what we call the program planner, how you are supposed to cover all the different topics you are going to cover this year in physics. So when you look at my screen, you can notice that these are the different topics we are going to cover. So in term one, we expect you that you are going to cover work, energy, power, and then the turning effects. In term two, these are the different topics you are going to cover. And then in term three, these are the different topics that you are going to cover. So I'm going to first ask you to take some 3 minutes and then take note of the different topics you are supposed to know by the end of the year. So you take note of them, you write your topic list such that when you are planning, when you are making research, you know which particular topic should I research about, which particular topic am I going to read about. So you first write these topics somewhere in your book. When you finish, you let me know through the chat that we have finished. Okay. From the chat, I'm not saying people have been finished, so we are going to continue. Now, as you are making your research, or when you are reading, these are the topics you must make research on. Like whenever you have your free time, you have some time, you can go on and be that particular person that can read ahead. So these are some of the topics that you can read through, or that you can plan for. And today, our topic is going to be work, energy, and power. Those are the topics that we are going to look at. So we are going to look at work, energy, and power. So that is the topic we are going to look at. So you can write your topic, the first topic we are going to look at as work, energy, and power. So this is the topic I want you to write: work, energy, and power as the topic for our session. So this study day, we are going to look at work, energy, and power. Okay, people are telling me they are done. Okay. Uh, Now, after that, we are going to go on and write the competency. The competence is the one that tells us that by the end of this topic, what should you be able to know? What should you be able to do? So by the end of this topic, we expect you that you are able to relate energy, you are able to relate work, you are able to relate force, and then the power in how the machines operate. So this is very important. Hmm. Okay, I want you to look at sorry. So I want you to look at the competence and then identify some keywords from this competence. Raise up the hand and you tell us which word have you been able to. Started WWA, one word,
Work done.
work done. Thank you. Sasha,
Energy.
energy, thank you. Hope members are taking note of those words. Queen,
Force.
Force. Thank you. Angel.
Power.
Power. Good. Thank you. Barbara. Oh, okay. I think uh, Samsung.
Machine.
Machines. Okay. Thank you. Stones. Okay. Okay.
Samsung.
So let's write those keywords. Let's write those as our keyword. Let's write those as our keywords. So they identify the word energy, they identify the work done, they identify the force, power, and then the machines. So those are some of the key words. So take note of them. Take note of them. Okay. Now we are going, even the ones you have given the chat, they are okay. I saw force from Clarissa. That was good. Okay. So we are going to continue. So these are our learning outcomes. We are not going to write them, but at the end of this particular topic, by the end of today's session, you are going to ask yourself, do I know the major sources of energy? Do I know the different forms of energy? Do I know how energy can be transformed from one form to another? Do I know the positive and the negative effects of energy? So those are the different things that you are going to look at in today's session. And that's where we are going to concentrate going forward. Okay, I have my first activity. Uh-huh. Someone can read for us. Yes, Barbara? Barbara, I'm failing to get you. Okay. Danson?
What are the what are the sources of energy we have around us?
Thank you, Danson. Members, can we raise up the hand? When you raise up the hand, for you just mention any source of energy you have heard about. So I'm going to ask Sasha, keep unmuting them as I write. Okay, call on the names as I write. What they mention is what I write. Sasha, are you unmuting them? Okay.
Yes, I am.
Okay, you call their name and then they unmute and tell us.
Barbara, Patricia,
The sun.
Okay, thank you, Patricia.
Buttress, Queen,
Animals.
I said animals.
Energy.
Okay. Mm-hmm.
Barbara, Samsung, SM, then those.
Have the moon and the stars.
Okay. Monsters. I'm writing everything they tell us. Then we shall sort out.
Queen,
Sorry, I had not lowered my hand.
Oh, good. Albert. Samantha. Samantha.
What?
Okay.
Myra.
Hot springs.
Claire.
Hot springs.
Claire.
Plants. Plants.
Okay.
George.
Wind.
Okay.
Beatrice Mugumu.
Okay. Sasha, now we can take on, you look through the chat and check out whether we can pick some answers from the chat.
Okay. Minerals, volcanoes, biogas, hot springs, wind,
Mhm.
water,
Mm,
plants, geothermal energy,
mhm,
energy, nuclear energy, hydro energy, wind.
mhm. Okay.
Um,
Oh,
that's all.
okay. Thank you, Sasha, and thank you, everyone. Yes, now all what they have mentioned, some are really sources of
Oh,
energy, but yes,
they are also fossils.
fossils, eh? Okay. Okay. Thank you. So those we have mentioned. Now I want us to classify them. We have mentioned quite many, but now I want us to classify them into what we call natural sources and what we call the man-made sources. So when you are raising up your hand, you are going to tell us which ones are natural and which ones are man-made. So you tell us, so you raise up your hand and then we categorize them into what we call natural sources and what we call the man-made sources. Okay, we start with Queen.
The sun under the natural sources.
We have the sun under the natural resources. Good, thank you. Samantha.
Wind under natural sources.
Wind under natural sources. Okay, thank you. Sharon. Sharon.
Sun under natural sources.
Okay, sun under natural resources. Thank you, Sharon. Claire.
Moon as under natural resources.
Okay, we have the moon under the natural resources. Okay. Thank you, Kilea. Daniela. Sorry, Daniela, come again.
We have water under natural resources.
We have the water under the natural resources. Okay. Thank you, Daniela. Galax. Oh, I'm failing to get Galax. Myra.
Hot springs under natural sources.
Okay. Hot springs under natural resources. Thank you, Myra. Buttress. Buttress. Okay, so you can notice that according to what they have given us, many of them have been able to give us the natural resources, but also we are going to learn that when it comes to sources of energy, we have like what they have mentioned, we have those ones that do just reflect, but actually they do not give energy, but they just reflect. But we are going to look at that at a later time. Okay, thank you. I have another. Where does most of the energy on Earth come from? Can you put your answer in the chat? They have mentioned some of them, but where does most of the energy we use come from? What do you think? Prosper has said sun, Nante sun, Wawa sun, Sharon sun. Okay, okay, okay. I think I agree with everyone that the most energy comes from the sun. Now, when you look at my screen, I have displayed some sources of energy. Now, these are some of the sources of energy. So I'm going to label these pictures. You are going to give us that specific energy that you think is being produced by what you are seeing. This is A, this is B, this is C, and this is D. So I want us to utilize the chart. In the chart, I want you to tell us the source of energy. You say A, this one gives us this type of energy. B gives us this type of energy. C gives us this type of energy. D gives us this type of energy. Can we first put them in the chat? Yeah, right in the chat. I would have allowed you to write on my screen, but I don't trust your... Okay, let me allow you to write on my screen. Oh,
Who's doing this?
I think your handwriting is really failing me. So allow me to first that we use the chat. Let's use the chat. Some of you are writing, but the handwriting. So use the chat. I'm going to read through to check out. We have started with A. A, someone is saying heat. John Caesar said A gives us solar energy. A, light energy. A, heat energy. Solar energy, light energy, heat energy, hydropower, heat, hydro. Okay, 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 okay. That is very good. That's very good what I'm saying. And when you look at these ones, we have them in Uganda. The one that I've not yet seen in Uganda, maybe I've not yet moved, but I've not yet seen this one. But this one, when you go to Jinja, you're going to find it there. This one is almost everywhere in Uganda. Even when you go out your room, you can see it. Then this one is also everywhere. And those who have moved those ends of Mayuge, or if you are coming from Mayuge, you may have noticed that in Mayuge, they have built a very big solar panel project that is going to serve the solar, this kind of energy to the people of those ends. It is very, very big. I think it's on around, I don't know whether it's about 10 acres. Yeah, I saw it that side of Mayuge. Then, let me put here, and I see whether people can as well be able to identify the kind of energy. This is picture A, this is picture B. Yeah, this is picture B. But these two pictures are a bit related. I want someone. Let me pick Gabriel. Do you want to describe something? Which kind of energy do we get? You first identify for us the picture and the kind of energy it gives. Okay. Yes, Gabriel? Oh, I'm failing to get Gabriel. WAW.
Yes. Picture A, that is biogas.
Okay, he's saying that's biogas. WAW.
Yes, sir.
Which picture are you describing?
As I finished, I said biogas.
Oh, biogas. Okay. Angel.
Yes.
Angel.
Picture A,
Picture A.
heat energy.
Heat energy. Okay. Thank you, Angel. Lampard Mwine.
B is biogas.
B is biogas. Okay. Lastly, iPhone. Okay. Now, when you look at picture A, I'm going to start with picture A. Picture A, this gas you use for cooking, the gas used for cooking, we call it LPG, which stands for liquefied petroleum gas. Sometimes, or you can call it the natural gas. So a natural gas is a source of chemical energy. Now, this energy is converted into what you call heat energy. And heat energy, you can call it thermal energy. So when you find heat energy, is the same as thermal energy. And that's the one we use for cooking. So the gas you see here, like some of you, you have these gas cylinders. What is inside here is that liquefied petroleum gas. And for it, it converts, or it is a source of chemical energy that gets converted into heat energy. So it's mainly used in ovens, those who have the gas, that is it. Now, what you are seeing in picture B, some of you have sugar canes at home. Now, those sugar canes you have at home are sources of energy. And when you look at picture B here, picture B is also another thing. But why don't you allow me? I'm going to drop a link such that you can first read and someone will come back and then you share with us. I'm just dropping a link for you such that you can first read about that energy I have displayed. Yeah, I'm just dropping a link. So I want you to click on that link. I have dropped a link there. But I'm also going to, let me see, I'm going to have that link here. For those who may not be able, you're going oh, to read about it. Oh, no. Okay, I think that's not the link I wanted. Hey, okay, but I've dropped a link there that I want you to use. But I'm also going to drop another link. And people, I want you to read about it. We are going to take some few minutes and read about it. Where is that link? Oh, okay. So what you saw, I got that from here. When you look at my screen, I want you to read about it before I tell you. So this is Kakira Sugar Company. And Kakira Sugar Company, I want you to first read through such that you can be able to pick some idea. Read through here. I will scroll. So I want you to read from here. And I'm going to ask to give you some questions from here. So you read through very well. Okay, let me hope you have finished to read. I'm going to scroll up a bit and people go on to read. Members, let me know through the chat whether you have finished to read. Let me know through the chat whether you have finished to read. Okay, some people have finished. Okay, good. So I'm going to go back. I'm going to go back. I'm going to go back. And I'm going to ask, what have you discovered or what have you read or what have you picked? Yeah, from that photo I've showed you. Or from that read. What have you? Okay. Yes, Sasha? Sasha, go on.
In the Kakira Sugar Factory, they get their power, their electricity from where they get their produce from. Example, when you're eating a sugar cane, you always bite it and then you suck out the juice and then you throw what has remained, that fiber. So in the Kakira Sugar Factory, after squeezing out the juice from that fiber, they don't throw it away, but they use it to produce their own electricity. They burn it up and then it produces some kind of steam, which is used to drive some turbines to produce energy. Yeah.
Thank you, Sasha. Okay. Danson, you want to add on?
I've picked that in Kakira Sugar Factory, they use electricity and steam to operate their work. That's
Okay.
all.
Okay, thank you. Samantha?
The in Kakira, those sugarcane fibers, I've learned that the source of energy is biomass, and it is used to run the turbines in the Kakira industry.
Okay, thank you. Yeah, now, the byproducts, although like after they have squeezed out the juice from the sugar cane, those remains that they get are these ones you are seeing here in the picture. These are the ones, and they call them bagasse, something like that, or begasse. These are the ones, so these are the ones they use in the generation of the power. So those people who live around Kakira, you may have noticed that Kakila supplies electricity around the people, around the community members, around Kakila, and for them, you never find them when their power is off. They have power year in, year out because their power is controlled within the factory. So you never find that power is off as long as they're on that line. And they have told that they supply quite a lot of power to the community. So they keep on running their machines using their byproducts. But also these byproducts, they can use them to make the briquettes, they can use them to make fertilizers. So there is quite a lot of things they can make from these things. Okay, I have other pictures here. So we are going to identify which source of energy. I have this is picture A, this is picture B, this one we have seen, this is picture C, and this is picture D. You just tell us for you which one you think you know. Samsung. Oh, sorry. Yes, Danson?
Picture B, light
Okay,
energy.
picture B is light energy. Okay. Could you have, okay. Yes, Lampard?
Picture D is thermal energy.
Okay, thermal energy. Rita? Thank you, Lampard.
I think picture C is heat energy.
Heat energy. Okay, good. Samsung, Samantha.
I think picture D is geothermal.
Geothermal. Okay, yeah. So those are the different things we know. Now, when you look at A, that's what we call coal. I don't know that you have heard about what we call coal.
Yes.
That is what you call coal. Then B here, this is mainly oil. This is like an oil refiner, like oil company.
Oil rig.
Yes. Then this one was basically for the heat energy that you are telling us. This was gas. And here, the aim was looking at what we call the nuclear energy. You have heard about
Ah,
nuclear things, nuclear bombs, and the rest of that. So that was mainly about that. But I think I would get better pictures such that you can be able to have a feel. But these black ones, that one is the coal that they are manufacturing. Now, the link I've sent you, there is a link I dropped in the chat. There is a link I dropped in the chat. That link has the different sources of energy. Let me drop it again. And I will take you there. Yeah, I want you we are going to take about 10 minutes when we are reading about the different sources of energy. So there are different sources of energy. So I want you to read about each in brief. What is wind energy? What is solar energy? What is biomass? What is hydropower? Geothermal. So can we read about it? Read about coal, read about oil, read about natural gas, read about nuclear physics. So I'm going to, I think, let me display here. I don't know whether you want to make some smaller notes, but it is okay. We can first make some smaller notes. Yeah, feel free to make some small notes, but we are going to take some 5 to 10 minutes. So you write about the different forms of energy, wind energy, the solar energy, the biomass energy, the hydropower. Yes. So I'll just be scoring as you make some notes about those different forms.
first wait. Energy in moving air harnessed by wind turbines used
Okay, let more people are reading through. I'm going to scroll a bit. Some of the sources of energy, where that energy comes from. That in case you see this electricity at home, where does it come from? In case you see the different, because sometimes at our homes we have opportunities of also generating our own power. Yes, Rita.
Teacher, I would like to ask about if you could explain more about geothermal energy. Yes, I'd like to know more about geothermal energy.
Okay, Rita, I'm going to explain. May I ask anyone who wants to say something on geothermal energy? Okay, Rita,
Yes,
have you studied in geography? Have you studied things concerning magma, those things?
no,
Not yet, eh? Now,
yes.
on the Earth's surface, there is some heat that originates from within the Earth's core
Mm,
as a result of the formation of the planets, eh?
yes,
Now, what happens that when that heat is generated and transferred, that's when we obtain that geothermal energy. But geothermal mainly like let me use a mountain. Like there are some mountains, I think some time back, you heard about a mountain that erupted fire. I don't know, you know that mountain. Have you heard about that mountain that
not
erupted
yet.
and we had only fire?
No,
No.
I usually
Okay.
don't.
Oh.
Cause me, well, like I can relate it to chemistry. When our teacher of chemistry was teaching us like about pressure,
Hmm.
it all about when these lands they come together and they forge together, like the land can come upwards. Now, when you talk about this thing of magma, I remember
Hmm.
like when magma flows out, like where it is collected from those holes that
Hmm.
it passes through, it
Hmm.
like when it comes like on like now the volcano is this side and this side the magma is flowing toward, like let's say volcano is in A and where it is flowing to is C. Now when
Hmm.
it's flowing to C, now that heat which is there causes the land
Hmm.
to like to be heated up. Now that heat which is inside that magma heats up where it is flowing and where it has settled. It heats up that land and you can see like steam or vapor comes from the land, and when you like pour or anything there.
Hmm.
Yeah, that's what I can relate in chemistry.
Okay. Now this, okay, thank you. Now, how do they get this geothermal? What they do, like they drill a well deep into the earth's surface, underground, like the way you see when they're getting water down the earth. So what they do, they drill down there. So underground there, they're like reservoirs of hot water and steam. Now, once those ones are brought out from down there, what happens? That the hot water and the steam helps to spin the turbines that are connected to generator, and then later on they produce the what? The electricity. So that's how we obtain that what? The geothermal energy. But it comes from the Earth's core down there. And this one, it comes from Earth's core and what you call the radioactivity decay. Like there are some materials that decay. And once they decay, like those things that died some years back, let me say 1,000 years back. So those are the ones that help to get that kind of energy. So sometimes they can get the dry steam, what you call the flash stream, and then the binary cycle. But it comes from after drilling wells deep into the Earth's surface. And once they drill them, they get access to hot water or steam. So this is similar to what we have. Is it at Chitagata? Something like that. That hot water that comes from the deep inside the Earth's surface. So it runs the turbines.
Thank you, teacher.
Okay. Okay, I'm going to scroll again such that people can as well be able to read about the coal and the oil. Sorry, Natasha?
Sir,
Yes.
I would like you to explain more about nuclear energy.
Okay. Nuclear energy. Okay, I'm going to talk about the nuclear energy. Have you heard about what you call nuclear bombs? So, nuclear energy. Now, to nuclear energy, there is a topic you are going to learn in physics, what we call nuclear fission and fusion. Now, nuclear energy is formed by what we call nuclear fission. Now, what is fission? Like whenever you have, let me say, atoms, you learned about atoms in chemistry. When you have an atom, an example of an atom we can have is uranium, is an atom of around 235. So when you have this particular atom of uranium, what happens? When this uranium splits heavily, it releases heat and what we call neutrons. Now, the heat that it releases is what forms what we call the nuclear energy. Like there are some atoms which, when they split, they form the kind of energy. So it releases a lot of heat. Now, that heat it releases produces steam, or there are some chemical reactions that take place. So it produces that steam which spins the what? The turbines that are connected to the generator for us to be able to obtain the what? The electricity. So what happens that whenever you have an atom, like I've used the uranium, when it breaks, when it splits, it releases heat. That heat energy is the one that produces the steam which runs the what? The turbines that are connected to generator to be able to form the what? The electricity. So this is a controlled process for nuclear fission, but that energy is formed by a process called nuclear fission. And there is a topic you are going to cover called the modern physics. There is a concept you look at what we call nuclear fission, and you look at the different equations that happen when a particle or when an atom breaks down. That when it breaks down, it releases this and it releases this. So, but here, uranium is one of the most common one that is used. It's like a reactor core that is being used. So once it splits, it splits down and it releases heat. So that heat is the one that is used to generate the electricity, because the heat generated produces the steam, and which goes on to spin the turbines. Let me hope I've given you a brief on that nuclear energy. Yes, Lampard.
Are there any examples of materials that produce nuclear energy when split?
One of them I've used is uranium. Is one of them. Uranium is one of them. Yeah. But I know you can find out others that can be used. But uranium is one of the uranium-235. Yeah. Okay. Let me hope everyone. Okay. So good enough. I sent you the link. You'll go on and read more about these different forms of what? Of energy. Or the different sources where we can obtain the what? The energy. So allow me to continue. Now, from there, these are the different sources of energy. Like we have what we call the conventional sources and what we call the non-conventional sources. Yeah. Then when we go on, uh, I know some of you at home, you have dung from cows, from other animals, you have firewood. Yes, so those are what called the non-commercial. Then petroleum, electricity, coal, those are the ones. Then we have those ones that are not so common. The ones that are not so common, you may not find people using them everywhere. Take an example, solar energy. It's not so common. People use it, but there are not so many. When you find wind energy, still there are not many. When you find energy from urban waste, still those are not many people that are utilizing that energy. Now, when we talk about convention, we are looking at those that have been used for a long time. So example of conventional, these are the ones you see on the left. Examples of non-conventional, these are the ones. Those are the ones that are newer. Those are alternative sources of what? Of energy. But for them, the beauty is that they are very environmentally friendly compared to the conventional ones, because the conventional ones, they have some challenges with them, as we shall see going forward. So, these are the different forms of energy. Like you can see, I don't know whether any of you can be able to note to tell us which area is this in Uganda, and which kind of energy we can get from there. You can type in the chat in case. Okay, WW I think knows that area. WW or Priska.
That is
Okay, George, what do you have to
in
send, Priska?
Kapchora. And see,
Okay, you are right. Yes, Priska? Okay, so those who have been to Captura, this is CP Falls. So here I'm trying to show you that the different sources we have, we can be able. So those who have been to Captura, you might have seen this for CP Falls. So now this water falling can help us to produce some kind of energy. I've put here. What I ask you is that I want you to check out what different forms of energy do you use at home. I have put some here, and I want you in the chat to tell us that this energy is called this energy is called this energy is called this. I have A is here, B is here, this is C, and this one in red is D. You put for us in the chat that A is this, B is this, C is this, and D is this. Which kind of energy do they produce? You need to know the kind of energy they produce. Okay, I'm reading some answers from the chat. Chemical, light, heat, sound. Chemical, that's very good. Yes, Rita. Rita? Rita?
I think A is chemical energy, B is light energy, and C is heat energy.
Okay, okay, good. Thank you. So these are some of the, what about D?
D is sound energy.
Sound energy.
And,
Sound energy.
and
Okay, good. So I'm going to ask you in your book, everyone, to first summarize the different forms of energy you see in the picture. Summarize that these are the different forms of what? Energy. So let's first summarize them. And feel free to give yourself an example. Eh, yeah, so you are summarizing the different forms of energy. Okay, people have finished. Good. Okay, so I'm going to ask you, we are going to have a discussion. We are going to have a discussion. I don't know whether we shall manage breakout rooms. Yeah, but we are going to have a discussion. I want you to read, to look at the picture, look at what the activity is saying. This is the activity. I want you are going to identify that one picture of your choice. You tell us the form of energy, the application, you tell us the side effects. It can be on the environment or on the human. We are going to just have just one or two people to tell us. Then the rest we shall do it at a later time. Yeah, but I want you, even you can first make your research. Because much as energy is good, but also we must look at the side effects. Much as you feel very good putting on your headsets, you need to know that there are some sins you may pay for at a later time. We start with Rita.
So I think part A for the picture, the form of energy in part A is solar energy. The application we use it to provide electricity in our houses. The side effects on the environment, like I really don't know that, but I can continue. The side effect on humans. I think I can give part B. Part B is heat energy. Where we apply it, we use it in cooking. The steam that it produces, it is toxic, which is dangerous to human health. Can cause also lung diseases, and the side effects on the environment, pollution. Yeah, that's all. And here,
Okay. Mm-hmm.
that's all I know.
Okay, thank you. Samantha.
On part B, we have sound energy. To
Mm-hmm.
the application, it can be used in entertainment, communication, and the side effects on humans may too much sound can cause hearing impairment, and to the environment, it can make animals like bees uncomfortable in their habitats. That's all.
Okay. Thank you. Danson.
That the type of energy in picture C is heat energy. Application, we can use it for cooking food. Effects to the environment, it leads to deforestation. Effects to
Okay.
humans, it it can lead to suffocation. That's all.
Okay. Thank you, Danson. XI. Okay. That one I'm failing. WA.
Yes, I'm talking about solar energy.
Mm.
This one is used for light. Then also in some cases can be used for cooking, and then so on. Then the side effect on the environment. This one in most places which are somehow bushy, it may lead to deforestation in the way that the an individual who's using it wants the sunlight to reach the solar panel directly. Short circuits, which may lead to burns in the way that those burns can lead to loss of lives. That is all.
Thank you so much. Stones. Oh, okay, I'm failing to get stones. Queen.
I'm going to talk about the solar energy.
Okay.
The solar energy, its use to us is, well, helps us to, when the sun hits the solar panels, helps us to watch television and signals and other things. But then my question was on the effects. Everyone was saying other things, but on the effects, can't you also say that next month, sometimes these solar panels can be expensive or costly? So isn't it one of the side effects that humans can have towards it?
Okay, as a side effect.
Yes,
Okay,
sir.
it would now depend on how you are going to frame it. I know they are very expensive, but here we are
Yes.
mainly concentrating at the energy that it produces, whether it has any side effect on the human person or the other person or the environment.
Okay.
Hmm. Okay. So, yes, Sasha?
I'd like to talk about picture B, the one
Hmm.
where they are woofers. So the form of energy produced there is sound energy,
Hmm.
and the application, these machines are used to enhance sound to large crowds.
Hmm.
So the side effect to the on the environment, in the environment you have different kinds of things like bats and birds. These species use sound to navigate their way since they can't see. But like I'm talking specifically about bats. They use the what? They use echoes to
Hmm.
locate to where to go. So if there is a lot of noise, they can't hear any echo, so it's hard for them to move. Then side effects on humans, too much sound that gets inside the human ear can cause damage to it. Then
Hmm.
yeah, that's it.
Okay, okay. Thank you, Sasha. Now, as part of your homework, each one of you, you are going to finish this activity here. You are going to make good notes for the side effects of each and what we call the on the environment and also on the humans. So you're going to make your work. I'm going to share it such that we can be able to do it. Now, at this point, I don't know whether Donald Trump it is a question. Donald Trump, is it a question? Donald Trump. Am I failing to get Donald Trump? I think I'm failing. Okay, so we are going to do an exercise. We are going to do an exercise together. So I'm going to share here a link, and I'm going to ask you to join in. Then we try out this activity to check out whether you have picked something concerning energy. So when you look at my screen, I'm going to ask you to go. I've sent a link. A link is there. Go to that and then put that code. I'm going to share it also on the WhatsApp. Those who may have challenges here, let me also share it on WhatsApp. So such that those who can get it from the app, you can as well get it from there, from the group. The code is that one. I've shared it in the chat. The code is there.
74200.
Shasha, what is it saying?
It's 72220.
Okay. Okay, I'm seeing 27 people have joined. I don't know whether we should start or I need to wait. Kindly let us know through the chat. Hey, that's the link. Okay, I'm saying we are 42. Maybe when we get to 50, we shall start. So just click on the link in case this can work. The WhatsApp, we have posted it there. We have posted it there. So when you tell me, we shall start. Okay, we are 50. Let's start. Okay. So be mindful of the time. Yeah. So here it will be showing you like your position. Yeah. Okay, congratulations. Those are so kindly let me know in the chat whether members want to see their results. Do you want to see your results? Okay. Okay. So according to the chat, I'm going to display. Good enough, there is one name, and then we see how we have performed. There were 18 questions. So the red shows you the number that you have not passed, and then the other one shows you the ones you have passed. So I can scroll. When you see this one, it means that the question was not answered, that maybe the person was still attempting, and then something happened, that the screen went on before he attempted. Hope you can see your name. Yeah, so that's how you have performed. Thank you. Yes, yes. So 69 of you were able to attend. And why don't you allow me that we end here the session? Now, what we are going to do next week, on this day when we have physics, we shall have 1 hour for math and 1 hour for physics, like that. But you can let me know which subject should we always start with. Either we start with math, then you go for physics, or we start with physics and then go with math. So you can let me know through the chat which subject we can start with. Either you can save one math, physics.
Hello.
Yes. Okay. People are suggesting we start with math. Okay, we shall do math for 1 hour. And then we have, yes, tomorrow we still have lessons. So tomorrow we shall still continue with the other lessons.